Okay, we solved this problem the last class. Problem number 5 has been solved, and the conclusion was to reject null hypothesis. Okay, that's what I am showing here. Problem number 6. Now we have to start. Read the problem one more time and collect the information given the problem. To find out whether a new serum will arrest leukemia, 9 mice, is it sample size? Let me check. All with an advanced stage of disease are selected. 5 mice receive, see, we are separating this 9 into 2 different samples. 5 mice receive the treatment and 4 do not. So there are two samples. One sample receives no treatment, call it from population 1. Second one receives treatment, so population 2, isn't it? So this one will give you compare the population mean. This one will compare the population mean too. In years, you can change. You can take this one as new one and this one as new. No problem. In years, see, survival time in years from the time the experiment commenced are as follows. Survival time again given with treatment, without treatment, isn't it? There are 2 cases. So at the 0.05 level of significance, so when you get level of significance, what is your confidence level? 95% you are confident about your statement, isn't it? Can the serum be said to be effective? Can the serum be said to be effective? So what is null hypothesis? Assume that 2 proportions are normally distributed with equal variances. You don't have the knowledge of variance in this problem. There is no sigma 1, but sigma 2. We are given assumption that they are equal. Sigma 1 square, sigma 2 square are equal and unknown. This is the case. Unknown. There is no sigma 1, sigma 2 of the population given in the problem. So we have to find S1 square from the first sample. This is our sample 1. We take this one as our sample 1. It is possible to exchange, no issue. We can take this one as S2 square. So from this sample we will find sample 1 square, that is S1 square standard deviation square, which is variance of the first sample. This is variance of the second sample, isn't it? We can find them, and we can find the x1 bar for this sample, which is the sample mean. Again, x2 bar for this sample. Now our assumption is both are equal. Null hypothesis will be always mu1 is equal to mu2. The question is serum is effective? So you say either no or one. Yes, serum is effective, which means that what do you conclude? H1. When you say yes, your answer will be serum is effective, isn't it? Effective means treatment, the mu2 is better than mu1, isn't it? So mu1 is lesser than mu2. This is our alternative. When you say no, they are equal. When you say no to the question, that is our null hypothesis. They are equal. Both the means are looking equal. So there is no difference. There is no significant difference between the treatment and non-treatment cases. That is our null hypothesis always. So when you say yes to this one, serum is effective, it means the treatment is good. Treatment gives much better outcome than the no treatment team. So mu1 is lesser than mu2. Mu2 is treatment of this, isn't it? This is our alternate hypothesis. So we decided the null and the alternate hypothesis. You can switch the terms. Instead of mu1 here, you can say this one mu1, this one mu2. It's possible. So you have to change the sign here. A symbol lesser will be greater than, that's it. And your sign of t test will also change. Everything will change accordingly. Okay, now what is the right formula given for this problem? This is sample 1. So the sample 1 gives you, this is a sample 1, gives you x1 bar. Find x1. First, let me write the formula. T test as There is no knowledge about variance. Variance is unknown. We should use t-test, and they are equal. So a pooled t-test. T is equal to x1 bar minus x2 bar minus mu1 minus mu2. You call it difference, isn't it? Difference is 0. You can also say difference is 0. Divided by SP, pooled estimation of the standard deviation. 1 over n1 plus 1 over n2. This is the formula. This is the formula for this case. You can check back the summary table and find this one. Okay? For two variances are unknown, which are equal. Okay, when the pooled t estimate will be used under this case. Okay. Now the point is, what are the things to be found? Sample size n1 and n2 are known. X1 and x2 should be found from the sample. What is the formula for SP? SP is square root of S1 square S1 square times n1 minus 1 plus h2 square times n2 minus 1 divided by n1 plus n2 minus 2. And for a t-test, and we need degrees of freedom, df, degrees of freedom, which is v is equal to n1 plus n2 minus 2. So S1 square is the variance of first sample, S2 square is variance of second sample, N1 is sample size, N2 is for second sample size, X1 bar, X2 bar. This term becomes 0 because there is no difference. That is they are equal. That's our assumption. So when they are equal, the difference is 0. Mu1 minus mu2 is 0. Okay. Here, I just erase this formula from this board. Now we will start calculating sample 1. The mean of sample 1 and the mean of sample 2 and variances are done. Then we will proceed. Okay. Now step 1 is make sure that you have written the null hypothesis. Test 0 is mu1 minus mu1 is equal to mu2. H1 is mu2 is better than mu2 performance is greater than mu1, isn't it? Okay. Now information. This is your first sample. We have assumed. So n1 is 4, n2 is 5. There are 5 elements here. 5. X1 bar. Sum the elements 1.9 plus 0.5. Use calculator. 2.8 plus 3.1 divided by 4. Divided by 4. Use calculator. This is 3.1. We will get 2.08. X2 bar for the second sample, this one, which is 2.1 plus 5.3 plus 1.4 plus 4.6 plus 0.9 whole divided by, there are 5 data, 5 data elements, 5. The answer is 2.86. So we collect the information here. X1 bar is 2.08, X2 bar is 2.86. Okay, now I erase this information. We will write n1 and 2. n1 is 4, n2 is 5. Now I can erase this calculatable part of x1 and x2. We will continue here. Okay. Now we have to find the variance of sample 1. Variance S1 square. The first data minus the mean, isn't it? 1.9 minus what is the mean of sample 1? 2.8. 1.9 minus 2.0. Actually, first write the formula of S1 square. What is the formula? Can you recall? 1 over n minus 1 summation I from 1 to 4, n is 4 here, xi minus x1 bar whole square. That is 1 over n minus 1 is 3 because n1 is 4, isn't it? 4 minus 1 is 3. First data 1.9 minus mean 2.08 whole square plus second term 0.5 minus 2.08 whole square, 2.8 minus 2.08 whole square, finally plus 3.1 minus 2.08 whole square. Sum all these differences, square differences, and then divided by 3. S1 square will be, so S1 square will be 1.3625. We don't want S1, we can keep S1 square alive. Okay. Fine. In the similar manner, I'm going to find here S2 square. S2 square is 1 over 5 minus 1 and sum of the squares of the differences 2.1. 2.1 minus the mean of second sample is 2.86. 2.86 whole square plus 5.3 minus 2.86 whole square. This should be done for all the 5 times. Last time is 0.9 minus 2.86 whole square. So when you do it by using calculator, the answer for S2 square is 3.883. This is S2 square, and we got S1 square. Using S2 square, S1 square, and N1, N2, we will find SP. So again, I am going to collect the information and erase the answers. S1 square is 1.3625. S2 square is, this is for this sample, this is for this sample. S2 square is 3.883, and now we will erase unnecessary parts. Now we are done with the variances. Next we are finding the SP, pooled estimate of the standard deviation. Okay, now let me start this one. The formula for SP is known, we have written in the beginning, so I won't repeat the formula. S1 square is this one, 1.36. I'm writing the answers, information and calculating the answers. So S1 SP is equal to 1.36. I can write 1.6625 into N1 minus 1, so it is 4, plus second variance 3.883 times, this is 4 minus 1, actually it should have been 3. This is 5 minus 1 is 4, and under square root denominator is n1 plus n2 minus 2. So when you calculate this one, you look at SP is 1.6474. We are ready with all information to find T. So before finding T, what is our second task? This is step 1. Step 2, we have collected information. Before finding the T value, T score by using the formula, we need to find the rejection area, isn't it? So alpha is given. Second part is here alpha. Alpha is 0.05 significance level. So critical region. How to find? This is a two-tailed test or one-tailed test. This is one-tailed test. Since rejection falls on the left side, all the entire alpha, when you go to T table, it will be symmetric about the mean, right? Here is 0 mean. So all the 5%, 0.05 rejection area alpha will fall on the left side. So there will be a T alpha. Negative sense is that the area falls to the left of T. And so the right side area, for some right side area, find the T value, isn't it? So now the left side area is 0.05 from the table. Now you understand the right side area is 9.95. Right side area is 9.5, isn't it? For degrees of freedom, V is equal to 4 plus 9 minus 2, which is 7. For degrees of freedom 7, if the area to the right is 0.95, find the T alpha value, right, in negative sign, isn't it? From the table. The table gives critical region is, so this is the area of rejection, so it will be in the left side of the T value. So T value from the table is negative 1.895. Negative says that alpha will fall on the left side, isn't it? For V is 7. That is critical region. Critical region is T lesser than negative 1.89. Either you can find the probability value for this one, or then you will find a T value. This is T critical, isn't it? Table value. Now we will calculate our T by using the formula and check where your T is falling. T calculated value is falling this side or this side, isn't it? If your calculated value falls on the left side, we will reject the null hypothesis. If it falls on the right side, we will accept the null hypothesis. Okay, now let me do the T value here. So we have to collect the information. SP, now writing the SP value here. SP is 1.6474. Okay, and T value, that is rejection area, critical region. T is less than negative 1.895. So we will erase the unnecessary part and then solve the problem in the same place. We will solve it here. Okay, now T should be calculated. X1 minus X2. What is X1? X1 bar 2.08 minus 2.86 minus, this is 0, mu1 minus mu2 is 0, divided by SP is 1.6474 under square root 1 by 4 plus 1 by 5. Use calculator to get this value, which is negative 0.70, isn't it? So where this one is lying, greater than, so in the right side or left side of the region. Here you find negative T values This is negative 1.895. Find here t value for which the left side area is alpha. So 0.0 is lying in this side. This will be 0.7, 0.7. And then you move towards point -1, -1, and then -2 moves left side. So this is certainly in the acceptance regions, isn't it? Since t is -0.70, falls in the acceptance region. Conclusion is we accept H0. We accept H0. What is your H0? There is no difference between the two teams, treatment and no treatment. That is the conclusion. So serum is not effective. That's it. Can serum said to be effective? No. So H0 is the answer for this. Let's go for the next problem. Only two more problems, and we will conclude. So collect all information. Similarly, similar type question, I think. Two sample means, two sample standard deviations. So they are assumed to be equal. The population, assume the population to be approximately normally distributed with equal variances. So the same. Now here we are going to use p value. That's it. That's the only difference. The information should be collected. X1 bar and S1 you have, isn't it? So you can find it. N1, what is N1 here? We can collect them. N1 is also 12 each brand. An experiment is conducted using 12 of each brand. N1 is 12, N2 is also 12. So what is degrees of freedom? 12 plus 12 minus 2, which is 22. And this formula, the same formula of the previous problem, the same formula. So SP should be calculated. The first assumption here, it will be given what is null hypothesis. Test the null hypothesis. Test the null hypothesis that there is no difference in the average. So H0 is mu1 not equal to, sorry, mu1 equal to mu2. Therefore, H1 is two-tailed. Mu1 not equal to mu2 because there is no other claim here. So we are testing whether they are equal or not. There is no difference or there is difference. Clear. So this is a two-tailed test. And p value, whatever you find, should be multiplied by 2. Okay. Now critical value, we'll find critical value. Alpha, what is alpha? Any alpha value is given? No, there is no alpha value given. So assume alpha is 0.05, isn't it? Since this is a two-tailed test, the alpha should be separated into two parts, and alpha by 2 will be in the left extreme, alpha by 2 will be in the right extreme, isn't it? So there will be a t positive alpha, t alpha over 2, here negative t alpha over 2. So this is the rejection area. What is alpha over 2? Alpha over 2 is 0.025, and degrees of freedom is given here 12. For this degrees of freedom and alpha over 2, what is the t value for the table? That leaves area to the right of t is 0.025. The same t value can be written negative side inside. So from the table we will find t is 2.074. Therefore the same value here in negative 2.074. So critical region, this is step 1 here. Second step, critical region. Critical region is t lesser than negative 2.074 or t greater than 2.074. This is our critical region, either the left extreme or the right extreme, isn't it? Okay. Now calculate the t value. I'm just calculating here t value. T x1 minus x2, same formula. X1 is 37. Well, we need SP. We need SP value to calculate uh, t value. So first we will find SP value. The formula for SP in the previous problem we have written that S1 square. Where is S1? This one square. 5100 square times n1 minus 1, 11 plus 5900 square times 11 n2 minus 1 divided by 11 plus 11 minus 2. This is the degree separation. So when you calculate, you will get SP as 5515. So I'm writing the SP value here. SP value is 5515. Now erase this part. Here I will erase the SP part, and then we will find the calculated value of t, and we will check it is falling in this interval. But we are asked to use p value here to conclude the problem. Okay. Okay. What is it? T value x1 bar is 37,900 minus x2 bar 39,800 minus mu1 minus mu2 will be 0 divided by SP is 5515 square root of 1 by 12 plus 1 by 12 1 by n1 1 by n2. Calculation will give you a t value is negative 0.84. Where does it fall? It will fall here. It will fall 0 negative, so it is lesser than. Greater than. This is here, isn't it? There's somewhere here negative 0.84. So we have to accept it by considering the t value. Obviously, we are asked to use p value, isn't it? So only I need this t. Now, what is your calculated t value? T value calculated is negative 0.84. Now, using p value, 2 times the area of left side or 2 times the area of the extreme right should be the p value, isn't it? Now I erase everything from the board. What is the p value? 2 times p of t lesser than calculated negative 0.84, or you can write greater than positive 0.84, isn't it? Since it is 2-tailed, we multiply 2 here. And now degrees of freedom is 22. Degrees of freedom, you should remember 22. Okay, there is no direct 0.84 in the t table. We have to find degree. We have to browse through the degrees of freedom 22 to find the nearest values of 0.84 on the t table. When I go to degrees of freedom 22 and browse the line, browse this row, we will find 2 different values which are nearer to 0.84. There is no negative value. Negative value says that the area is left side. So in the t table, we will finally show you after this problem. There is a 0.832 and there is another 0.858. The top value reads alpha is 0.3 here. The alpha value will be 0.2 here. It means that t value, the p of 0.84, isn't it? It means that alpha value 0.2 lesser than probability of t lesser than negative 0.84 lesser than 3. Okay. 0.3. When you multiply by 2, it will be 0.4 lesser than 2 times probability of t lesser than negative 0.84 lesser than 0.6. It says that p value lies between these two values 0.4 and 0.6. In between the p value lies. So p value is greater than p value here is greater than 0.05. So accept H0, that's a condition. Now how did we find this one? There is no direct value for t, which is given as 0.84. So we find the nearest values of t and find what are the alpha values, isn't it? So that will be our interval. That's the end of this problem here actually. I will show you t table now, where we cannot find 0.84 but the nearest values. So this is t table. When I don't find 0.84 here, go to 22. There is no 0.84 on the 22 degrees. Second table, 22. It's not here. Let me carefully check here. 22 here. You will find here 0.532, not 83. Between 0.532 and 858. Between these two values, 84 will be falling, isn't it? So 0.532 here. So 0.532 here for 22 degrees of freedom. T value lies between 0.532 and 0.858, which are lying in 0.3 and 0.2, the top. Isn't it? So alpha values are 0.2 and 0.3. So P of the T value from that system. No, note down. This is 532 858. Well, that is what we say. 0.532 is some t value is 0.84 lying between these two, 0.858, which gives alpha here. It is this one, isn't it? But the number is here. It is 0.2. Probability of t is probability of t is negative 0.84 lying between these two. Multiply by 2, you'll get 0.4 less than 2 times probability of t less than negative 0.84. So this is our p value. P value lies between these two values. It should be, therefore, p value should be greater than 0.05. So accept H0 is the answer for this problem. I think I can give you 2 minutes time, but only one more problem. I'll give an idea and we'll stop this problem. See, the same method we are going to work on, but the formula is different. You should be careful about the formula. This deals with the population proportion, and the formula that approximates this with normal distribution is Z is equal to P cap minus P divided by square root of P cap over N. This is standard error, this term is right. And P cap is the probability of success in the sample. P is the population probability. Q is the probability of failure, and N is the sample size. We need this information to find Z table, Z calculator value, and then find table value, compare this one. That is it. So a marketing expert for pasta making company believes that 40% of pasta lovers prefer lasagna. 9 out of 20 pasta lovers choose lasagna over the pastas. What can be concluded about the expert's claim? What is the expert claim? H0 probability P is 40%, which is 0 population probability is 0.40. Our alternate hypothesis is P not equal to 0.4. That's all. Not equal. Let it be two-tailed test. Alpha 0.5. So critical region, what you find is alpha is 0.05 and two-tailed test gives alpha over 2 is 0.025. This area is alpha over 2 and this area is also alpha over 2, which is 0.025. So what is this z value? We'll compare approximately the z value. From the table, the area that is the left side of this z is the area left side area will be total left side area will be 0.975. For that value, you find z value in the table. This will be z is equal to 1.96. Here it is then negative. Z is negative 1.96. So any data falls in this interval will be accepted. This area is area of projection, right hand and left hand. So critical region is it lesser than negative 1.96 or is it greater than positive 1.96? Now calculate z value. What is P? Here 9 out of 20 is P cap. 9 out of 20, which is 0.45. Obviously Q cap is 0.55 because 1 minus P cap, isn't it? And what is sample size N? 20. 20 past hours are been calculate this value. P cap minus P population parameter divided by P cap times Q cap divided by N. That is equal to P cap is 0.45 minus 0.44 divided by square root of P cap 0.45, 0.55 Q cap or divided by 20. When you calculate the z value will be 0.4495. Where does it fall? It falls here. This is 0, somewhere here 0.4, then it moves to 1. So falls in the acceptance region. Therefore the conclusion is accept H0. That's the end. The next problem is your practice problem. The same way you can try. This is a practice problem. And thank you very much for your passion watching. And good luck for your quiz.